Since December 1972, human space exploration has hit a hard ceiling. Every astronaut launched into the vacuum has remained tethered to low Earth orbit, traveling no further than a few hundred miles above the surface. Artemis 2 is designed to break that 54-year limitation. This mission is not a lunar landing, but a mandatory deep space test flight, a prerequisite to prove that current hardware can survive beyond Earth's immediate magnetic protection. The 4 crew members tasked with this inaugural flight are Commander Reed Weisman, pilot Victor Glover, and mission specialists Christina Coch and Jeremy Hansen. Escaping Earth's orbit requires more than just raw power. It demands a flawlessly functioning, human-rated machine where every valve, circuit, and software line performs exactly as predicted. The mission begins at dusk. The 322-foot Space Launch System rocket ignites on the pad, generating over 8.8 million pounds of raw thrust. Within seconds, the vehicle clears the tower and rapidly accelerates toward an orbital velocity of 17,500 miles per hour. This diagram illustrates the flight path into a highly elliptical high Earth orbit. Stretching 38,000 nautical miles, this orbit is a 24-hour safeguard. If critical systems fail, the crew has the necessary geometry for a rapid abort back to Earth. This 24-hour window serves as the final checkpoint. Each system must perform within its design limits before the crew is cleared to move into cis-lunar space. The testing begins with a physical separation. The Orion crew capsule detaches from the interim cryogenic propulsion stage, or ICPS, leaving the spent rocket motor floating nearby. Pilot Victor Glover then initiates the proximity operations demonstration. He disables the automated guidance and takes manual control of the spacecraft. Glover uses Orion's 24 thrusters to align the capsule with a target on the discarded ICPS stage, holding exactly 30 feet. This manual handling data is required for Artemis 3 and 4, where crews will manually dock with lunar landers. After 70 minutes of controlled approaches and retreats, Glover completes the assessment. The exterior maneuvering hardware passes its first live trial. While the exterior mechanics succeed, the mission also depends on the extremely tight reality inside the cabin, a space roughly the size of a camper van. During initial checks, the crew reports a sudden anomaly, a blinking fault light on the spacecraft's Universal Waste Management System, or compact space toilet. On a 10-day journey, a failed waste system is a mission-ending threat. Without functioning hygiene hardware, crew health and morale would critically degrade long before reaching the moon. Mission specialist Christina Coch coordinates with ground engineers in Houston to diagnose the fault. She traces the issue to a sensor logic discrepancy in the system's controller and performs a software reset, restoring the toilet to normal operation. Resolving this unglamorous life support glitch serves as the final technical hurdle. With the interior systems verified, the mission can transition into deep space. On the evening of April 2nd, the crew straps back into their seats to execute the final critical engine firing. This diagram maps the translunar injection burn, the point of no return. The main engine ignites for 5 minutes 55 seconds, accelerating the spacecraft by 1,274 feet per second into a free return trajectory. Lunar gravity then captures Orion, slingshotting it back to Earth. When the engine shuts down, the test phase in Earth orbit concludes. Artemis 2 is now a committed deep space reality. A moment of wonder. From the capsule window, the glowing expanse of Earth visibly shrinks, rapidly receding into the absolute black of the void. The 54-year ceiling is broken. The Orion spacecraft coasts toward the lunar far side, carrying humans further from home than any generation since the 1970s. Successfully verifying the hardware during these first 2 days confirms the Orion spacecraft is ready for the deep space environment. It moves the program beyond testing and into the operational phase for future lunar missions.